Hello, everybody. Welcome to your first virtual lesson because I am out today. So, you should have received a packet. This should be what the front page looks like. It should say Congruence versus Equality, Unit 1 reference sheet. We are going to get to that a little bit more when we actually get into congruence, but it will be what we reference back to. For today, we are just going to kind of skip past that page and we should jump down to lesson 1.1, points, lines, and planes. And that is where we're going to start. So these are kind of the basics of geometry. And so we have what we call undefined terms. And so these are kind of terms that can only be explained using examples and description. So the first one we would consider is a point. So a point is a location. It has no shape nor size. So when we draw a point, we're not physically talking about a point. We're talking about a location, a place. So it doesn't matter whether you draw a point like this or whether you draw it like this. It doesn't have a size. We consider those both essentially the same. And so these are named by a capital letter. So for example, if I drew a point and then I put A next to it, we would call this point A. And so that would be our first term. Our second term would be a line. And so a line is made up of points. But it has no thickness or width. So when we're talking about a line, we're really saying, okay, if I put a bunch of points one after the other over and over and over and over again, eventually it's going to create a solid line. And so really a line is just a large collection of points there. And so there is exactly one line through any 2 points. So the way that we can name a line, we have more options than we do for just a regular point. So we can name it using 2 points on the line. Or we can name it using a lowercase script letter. And by script, it's kind of like a cursive letter. So for example, again, if I have any 2 points, there's going to be only one way to draw a line through this, right? It's going to be connecting the first point to the second point. So we'll call this point P and this point Q, right? Because, and don't draw this would not be considered a line because it's not connecting those two. So again, there's just one way to perfectly connect these. And so a line looks like this between those 2 points with arrows on the 2 ends. So the way that we name this is, again, we can name it with the 2 points. And we would do that by putting the 2 points next to each other, PQ, and then drawing an arrow or drawing a line with 2 arrows on the end points going in either direction. So this would be one way that we can name it. Now the order of these points doesn't matter. So we could also call it line QP, right? And again, we pronounce these as line PQ and line QP. They're the same thing, essentially. Now, we can do it that way. We can also write it out and say, okay, line PQ and line QP. All of these mean the same thing. Now, you also might see next to this a little lowercase letter like an M. That M is not a point. That M is a reference for the line. It is that lowercase script letter. So we can also call this line lowercase m. Okay, we can't call it line M and put an arrow on top of it. That's only permitted for the 2 points. So we do have to be kind of careful with that. So these are all of the possible names for this. So again, what I mean by that is we can't do this. This is not an option. We can just call it line M with that lowercase script letter. So these are all the ways that we could name this specific line. Now, if there were additional points on it, say like a point here, and we called that Z, we would have a lot more potential names for it, but we're not worried about that right now. So the next thing is a plane. And so a plane is a flat surface made up of points that extends indefinitely in all directions. Okay, so planes are a little bit difficult because when we're talking about planes, we're trying to write essentially a 3D figure in a 2D space. So when we draw a plane, we draw it something like that. But we have to keep in mind that what this really means is that it's going to keep going in all of these directions. So it's as if we took the floor and we just extended it on forever, that would be considered a plane. So there is exactly one plane through any 3 points. So similar to a line, but a little different because it's 3 points. We name this with a capital script letter. So we can name it with a capital script letter, or we can name it by the letters, naming 3 non-collinear points. Okay. And so what non-collinear means is not on the same line. So collinear, co meaning kind of same, linear meaning line, would be on the same line. Non-collinear would be not on the same line. So again, let's draw an example of a plane. So it doesn't have to be perfect, something like that. And let's say on here it has points B, C, and D. And then down here in the quarter is a script K. So we know that this can be referred to as plane K because that K is going to be in script. It's a little hard when it's my handwriting, I know. But do we see how there's no little point next to that K? That's what's indicating that that is referring to the plane rather than a point. Similar in the line, we don't have a point next to this M. So that's how we know it's referring to the line rather than a point. So we can call it plane K. And then these 3 points here are not collinear. They're not on the same line. Now, if there was a point here, we wouldn't be able to name it with those 3. We have to be using 3 points that are not on the same line. And so we can call this plane BCD. We can call it plane CDB. We can call it plane BDC. We can call it plane CBD. We can call it plane DBC. And we can call it plane DCB. So these again are all viable names. Now, unlike the line, there's not like a shortcut to kind of write these names. You have to write out the word plane, kind of similar to the way you have to write out the word point. And we do want to make sure we're writing out points so we know whether we're talking about a point or whether we're talking about a plane. But any of these would be viable. You would not have to write out every single one of these when you're doing a problem. Any one of these would suffice. This is just to list out kind of all of the possibilities. So the next thing we're going to talk about is collinear. Again, we've talked about this a little bit already. Collinear, co meaning same, linear meaning line, are points that lie on the same line. shockingly enough, non-collinear are points that lie, or that, I'm sorry, that do not lie on the same line. Crazy, I know. Okay. Similarly, coplanar are going to be points that lie on the same plane. And non-coplanar are going to be points that do not lie on the same plane. Real complicated vocabulary here. Okay. So let's get into some examples then. So we are looking at this figure over here, and it says we want to name the following. So we want to name a line containing point W. So we're looking here, we see that we have point W. So we have a lot of options for names. It says we only need to name one. I'm going to name more than one just so that we can have some examples. So again, we see this little lowercase script n here, right? There is no point next to that n, so that's indicating that the entire line could be called line n. Okay, so that's one option. Now, we could name it using W as a point or not. So we can use W along with any other point, V, X, Y. All of those would work to name that line. So we could say, okay, W, X with the arrows on top. This is referring to the line. Okay. We could also say using 2 points that don't include W, right? V and Y are both on that line. So we could say, line VY. If you don't like the little arrow notation, you could also say, okay, well, we'll say line and we'll pick 2 other letters. We can say V and W. Both of those are on the same line. So all of these are viable options here. And there's more. There's way more than just this. So it said give a line. So really you only need to give one of these, but I just want us to get used to there being more than one name. Okay. So the next one says a plane containing point X. So here we're looking at point X. We're looking at this point right here. Okay. And so we have a couple of options for how we want to name this. So again, we see kind of down in this corner, we have an uppercase script letter. There's no point around it. That is referring to the plane. So we can call this, if we want, plane P. Okay, because again, we're talking about this kind of blue plane here, this flat plane. So again, we can also name planes with 3 non-collinear points. So we could not name this with saying plane XWV because we see that they're all on the same line. And so that wouldn't be allowed. Now, we could name it and say, okay, plane X and W are on the same line, but then we could pick point Z, which is not, and that would allow us to call this plane XWZ. So that's totally fine. Again, we also couldn't call this plane XYV because those are all on the same line, but if we get rid of one of those and say Z, okay, well now they're not all on the same line, and that would be an acceptable name. So we could say plane, or we don't even have to include X. We could even say plane WYZ. All of those are permitted. And there is way more, but those are the ones we're going to list today. Okay. So then we have a plane containing points T and Z. So we have T here and we have Z. So again, we need to think about this in a 3D space. This line is going through this plane. So we actually don't have a plane listed or shown to us that goes through T and Z. But we have to kind of use our imagination to say, okay, there is a plane that exists. It's just not drawn there, but it does exist somewhere in there. So we have to kind of use our imagination a little bit. And so one example of this, what if we would say plane TZ, and then, okay, we'll say it goes through T, Z, and let's say it also goes through X. It also is containing X. So we can say TZX. Now for this one, because we are kind of creating a plane that we can't see, we do want to include those 2 points that it already listed out for us. So there again are more options. You could say plane TZ and then V. It would look maybe a little different or maybe more like this or so. But that would be another option, TZV. And there is so many more. So just because a plane is not drawn in our figure, it doesn't mean that there isn't one that exists there. So we do kind of have to use our imagination there. And then lastly, we have a line containing point T. So here we have point T. Again, we have a couple of options for naming. We see this little lowercase r down here with no point connected to it. That is referencing that line. So we can call this line R. And this line has a few less options. So we could say TX if we wanted, because those are going through the same line. We're still talking about this. So we could say TX with the bar on top. Okay. We could also say line if we wanted to switch up the order, XT. And there are a few more, but we can really only use TX for this line because there aren't any other points on the line. So those are really our only options for points. Alrighty, so we have a couple of properties here. We know that 2 lines are going to intersect at a point. So any 2 lines that we have that do intersect, there are situations where lines don't intersect and they look at like this. They're called parallel, if you remember that from Algebra 1. But if 2 lines are going to intersect, they are going to intersect at one point. In this case, it would be point P. Now for the second one, 2 planes are going to intersect at a line. So again, there is situations where planes don't intersect. They're parallel planes. That's totally fine. But if they are going to intersect, they are going to intersect at a line like this. So they intersect here at line R, and we do see that. So it's always kind of a step down. Lines intersect at points, planes intersect at lines. So we are going to have to draw a little bit in this class, and we're just going to kind of draw it to the best of our ability. There's a couple of options. This printed a little weird. Sorry about that. So this QR should look like that. But it says QR intersects plane T at point S. Okay, so there's a lot going on. So we know that we have a plane, so let's start by drawing that. You can draw it kind of however you want. I'm just going to draw it kind of a little flat if I can. Oh, that was bad. Okay, let's try that again. Okay, and this is plain T, so I'm going to put an uppercase script in the corner with no point, indicating that it is plain T. And we know that this line is intersecting just at point S. So we know it's not on the plane. It doesn't look like that. It's just going through the plane. So again, we kind of have to use our imagination. So let's say we have this line and it's hitting the plane. And then I'm going to draw some dotted lines to show it's going like beneath the plane. So it's a little hard to visualize, but it's like if you had a piece of paper and you shoved a pencil through it, that's essentially what's happening here. Right? So this is line Q. This is Q, R. And it is intersecting here at point S. So it's intersecting again if you had a piece of paper and you shoved a pencil through it, where the pencil meets the paper would be that point S. And so this would be an example. There is more than one way to do this. Okay, so the next one says line P lies in plane N and contains point L. So again, let's draw a plane. We'll start with a plane. Oh, my planes are not looking great today. But we'll call this plane N. Again, uppercase script letter in the corner, and that's how we know it's a plane. No point next to it. And inside of plane N, because it says line P lies in, so this time instead of going through, it's like the pencil's kind of laying on top. It looks kind of like this, right? And this is line P, so we're going to do a lowercase script. kind of on the end there. And it contains point L. So somewhere on this line, we have to have point L. Okay. And so that would be an example of that. All right, so it's going to take time to get used to kind of drawing, and it just takes practice to try to visualize these 3D figures in 2D spaces. But you'll get used to it. It just takes time. So we're looking here at this problem. I would like you to try some of these on your own, but it says, answer the following using this figure. How many planes appear in this figure? So again, we have to use some visualizing. So if we're looking first at this piece, we have one here. There's one in the back. There's one back here. There's one on the side here. And then there's one in the front. So this figure is giving us 5. Okay. And then we also see that because the base is a 5-sided figure. So we know that it's going to produce 5 sides on this pyramid. Now, we could include the base, but the base is actually part of this entire plane. So so if we count that plane as 1, altogether we're going to have 6. And my pen stopped working. Sorry, guys. We're going to have 6, okay? Because this would count as 1. And so that would be how many planes appear in this figure. Again, there can be more than this that exists, but they just showed us 6 in this picture. So then it says name 3 points that are collinear, meaning, again, on the same line. So you have a couple, well, actually, you really don't have many options here. The problem is if we're looking at F and G, they would be collinear, right? But there's not a third point there. The same thing with L and M. They're collinear, but there's not a third point. So really the only option we have for collinear with 3 points would be this one. So we would say, again, we want to specify point J, point K, and point D. And we want to use points so that we know we're talking about a point rather than a plane. Okay. So next thing it says is name the intersection of plane HDG with plane X. So HDG is talking about this one right here. And plane X, again, we see that uppercase script letter written down here with no point next to it. So that is what's referring to this bottom plane. So we want to say, well, where do those intersect? And so hopefully we can see that, okay, this line HG lies on both of those planes. So that would be the intersection. And again, 2 planes, plane, are going to intersect at a line. So it would be line HG. You can also call it GH. There's lots of options there. Okay. So let's see. At what point does line LM and EF intersect? Again, we have 2 lines, so that means they're going to intersect at a point. So we have line LM, so that's referring to this line that's kind of going through the plane. Again, we can see that because of this dotted part, LM, and EF. So this is a little bit tricky. Do these intersect? So looking at this, we would probably say no, right? They don't intersect in a way that we can see. Now, one thing again about geometry is this is a 2D figure or a 3D figure on a 2D plane. So we do actually have to consider the fact that these do extend further and potentially intersect. But again, because this line is going straight through the plane, this dotted piece is not going to intersect even if we did extend the lines. There's no option there. So this is actually kind of a trick question. They don't. They don't. And that's because, or in partial reason, LM is not on the same plane. Plane X, right? We know that EF is on plane X, But LM is not. So we could argue intersections with kind of all of the other lines because they're all on the same plane. But because they're not on the same plane, we really can't see that intersection happening. Alrighty, our points E, D, F, and G coplanar. So we have E, D, F, and G. What do we think? The answer is no. So now if we said, is E, F, and D coplanar? Yeah, they're all on this back plane here. And if the question was, okay, are D, F, and G coplanar? Yeah, that's right. They would all be on this plane. The problem is that if we're looking at all four, they're all across two planes rather than just one. So the answer would be no. Okay, at what point or in what line do planes JDH, JDE, and EDF intersect? Okay, so let's look at that. Let's start with plane JDH. So JDH, we're referring to this side plane here. Okay, and then we have JDE. JDE, we're referring to this kind of back triangle here. And then we have plane EDF. EDF. EDF here. We're talking about that plane. So it's saying at what point or in what lines do these planes intersect? So we have 3 planes here. And so normally 2 planes we know intersect at a line, right? These 2 planes would intersect here, these 2 planes would intersect here, and so on and so forth. The problem here is we have 3. So in this case, they don't all intersect on a line, but they do all contain this point D. And we even see it in the naming. They all contain this point D. So they all do intersect, but specifically just at that point D. So when we start going from how do 2 planes interact to how do 3, 4, 5, 6 planes interact, the intersections could be points rather than just lines like we talked about before. Alrighty, I know that was a lot, but you just need to practice it. So that's the biggest thing. So make sure that you are doing your homework. And have a good one.